In these two problems, in section 6.6, numbers 17 and 19, what we're supposed to do is state which values of x have to be excluded because they'll give us division by 0. So look at this first one right here. What values can x not be? Essentially, most of the time we can do this in our heads, but essentially what we're doing is saying this. Suppose x plus 3 is 0. What's going to make x plus 3 equal to 0? So we've got a little linear equation we can probably solve in our head. That's this one here. And this one here, what's going to make x equal to 0? Well, there's nothing to do here. It's just what's going to make x equal 0? 0. So we're going to say here that x cannot equal negative 3 or 0. Now look over here at number 19. What values of x will give us 0 in the denominator? So what we're looking at here is x plus 7 times x minus 6 could be 0. And this takes us back to solving quadratic equations, right? When we factored them, what we know is that x will not equal negative 7 from this one, right? If x is negative 7, and positive 6 from this one. And over here, what we're thinking about, 3x plus 2 being 0, well, we know how to solve this, right? We're going to subtract 2, divide by 3. This is just what we did when we were solving quadratic equations. So we change the sign of the constant, divide by the coefficient. So we're going to get from here, x not equal to negative 2 over 3. So all in all, we're going to say x cannot equal negative 7, 6, or negative 2 over 3. You know, while we're here, let's just go ahead and do number 21 also. It's very similar to 17 and 19, just a little bit more to it. So here's 21. It's 1 over x squared minus 2x minus 8, and then plus 3 over x squared minus 9 equals 0. And we're being asked to determine which values of x can we not use, which values of x will make the denominator 0. So the first thing we should do is let's factor these denominators. We know when they're factored, we can see what's going to make them 0. Let's rewrite the whole thing, but with factored denominators. So how about this? We're going to get x and x, and I'm thinking of 4 and a 2 with a minus 4 and a plus 2, and x squared minus 9, difference of two squares, we can get conjugates. X and x, 3 and 3, one's plus, one's minus. Now, just looking at these denominators, we know what's going to make this 0, right? If we said equal to 0, what's going to make it 0? Change the sign of the constant, divide by the coefficient, which is just 1. So what we're going to get here is x equals 4 and negative 2, right? We'll get the 4 from here, change the sign, and negative 2 from here. Negative 2 plus 2 is 0. Now from over here, change the sign, we'll get negative 3. So we'll get negative 3, and then from this one over here, we'll get positive 3, right? Change the sign and divide. So we'll get a positive 3 here. So what we're going to say is that x cannot be any one of those four numbers.